Welcome back. In this video, we've already got a few matrices working in our workspace. So right now I'm interested in this matrix G, which is a 7 by 3 two-dimensional array, or a matrix. It doesn't matter what's in it, but if you have a 7 by 3, then you can follow along. Let's use something new here. We'll call this section indexing. I want to know, how can I refer to an individual element from the matrix? So refer to an individual element from the matrix using an index. How do we do that? We use parentheses. So whenever parentheses are used with a matrix, it means we're trying to get inside and read data out of it. Let's take a look. So if I wanted to say G and I want the, I don't know, the very first one, G1, just tell me what it is. So I'm not doing anything with it. There's no operation or assignment. I'm just saying, tell me what's the first element in matrix G. Now we can see it. It's going to be -1. Let's run this section. We get a -1. But what if I said, what's the 9th? Where is the 9th element in matrix G? That's a little bit of a different question. So let's move this down a little bit and look at G real quick. There's a lot of elements. I can see it's a 7 by 3. There's 21 elements total. I bet 21 is this one down here, but where's number 9? Let's run it and see what we get. So G1, I'm going to suppress that output and just get the output from G9. I got a 3. Let's see if we can figure out where that is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, it's not that one. Let's try counting the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So MATLAB is counting down each column first. When you are indexing using a single number, a single index, the numbers run down each column and then up to the top, down that next column, up to the top, down that next column. So this would be column index number 14, 15, 16, and so on. All right, let's try a slightly different way of indexing. We can also say, tell me the row and the column. So now I'm not pulling out a specific number, a specific index by a single number. I'm giving the coordinates of the row number and the column number. So if we look over at G, row 4, column 3 again is 3. Let's try row 5 instead. That way we'll know we get a different answer. So row 5, column 3 should be 1. Let's run it and see what we get. There's our 1. So that's exactly what we expect. With two inputs, this is row by column. Okay, and there is a comma in between those two so that it knows what we're doing. Let's try G22 and see what happens. We said this is a 7 by 3 matrix. We get error. Index exceeds array bounds. So MATLAB is trying to help you out and say, hey, the array isn't that big. Your index has gone too far. That's what exceed means. All right, let's say, what if we want to assign something? So I'm going to say G53. Remember how we looked at that and it was a 1? Let's put in -100. That'll be easy to see. So we are assigning to the place of G53. So this is just like a variable name here, except it's a specific element inside of an array. And we are assigning to that spot the value of -100. Let's run that. I'm going to comment out the error causing one. And let's see what we get. So run section. And now it's reporting, because I didn't suppress the output here, it's reporting the whole matrix for me, and there's that -100 in place. So now we have MATLAB filling in something. Okay, let's try, let's go back to matrix F here. Matrix F is a 1 by 4. If I try to assign matrix F number, let's say 7. Remember, it's a 1 by 4. I'm going to assign it a 12. What do you think will happen? You think we'll get an error? Surprisingly, no. When you try to assign a new element that doesn't exist, that exceeds the array boundary, MATLAB's going to do it. It's going to create it if it can figure out which direction to go in, and it's going to fill in zeros everywhere else. So we have filled in with zeros all the way until we get enough places that MATLAB can put a 12 where you asked for it, F7. Now, if I were to do G in, like, let's say there's 21 elements there. If I tried to do G30 equals 999, this one won't work. See if we can figure out why. Run section. Attempt to grow array along ambiguous dimension. With F, it was a one-dimensional, so it just kept going in that one dimension. It knew where to go. G is a two-dimensional array, and it doesn't know whether you want to grow this way or this way. So that's what this means by ambiguous dimension. So this won't work. Won't work, ambiguous direction. It doesn't know which way you want. This works. So I'm going to comment this one out because it does produce an error, and instead say, well, what if I said G 9, 5? Well, let's do 9, 3. So remember, G only has 7 rows. It has 3 columns, so the 3 is not a problem, but the 9 is outside of the array bounds. The difference is we're telling it which direction to go. We say we want there to be 9 rows. That's what this means. So if I make that equal to 999 and run section, now I have expanded to 9 rows. It's filled in zeros everywhere it needs to, but it's not ambiguous anymore. So it knows which way to go. All right, that's all for now. I'll see you in the next video.